Welcome, everyone. Welcome to the third session of the journey of the industrial analog data. So, thank you very much for tuning in to various people from various parts of the world here right now. This, of course, is the third one, and we're concluding with this one. This is the last one of the session of the series. We started with data exchange, where we spoke about how analog data originates, industrial data originates at analog data, converts to digital. So this moves, the data exchange part moves from one point to another. And in the second session, we spoke about basically extending the same theme, but about how data now transforms itself from raw data to perhaps meaning something more to different stakeholders in the ISA 95 pyramid, and including the transformation of the physical layers as well. Now, all of this is, of course, made possible, by what we call industrial communication protocols. They bring the connectivity, the exchange alive, and there are so many of these in the industrial world. So today's session is about industrial protocols, and as I said, with so many of those, we'll structure it a little differently. We're going to talk about some of the applications, and I'll talk a little more about those later, and bring in the relevant protocol and the various, views of the two people that we have on the panel today to talk about the applications and the protocols and why do they make sense for those applications. Before that, just quick housekeeping points. Like always, this is a 60-minute session. So 50 minutes, we will use for the questions and around protocols and the applications. The last 10 minutes, we will use it for questions from our audience who have tuned in from LinkedIn. So before I get started and have the panel members introduce themselves, first of course is Jegajith. Jegajith, some of you have of course met in this session prior to the first session. Jegajith heads our embedded business unit, an out and out, embedded guy and connectivity guy, loves developing products and heads our, contributes to the pre-sales effort, delivery and sales, who wears multiple hats, but an out and out, techie who loves his field. And then Chatrapathi, of course, again, a lot of you have met earlier as the director of our industrial communication business unit, an OPC expert, also an Ethernet IP, ODBA represents us in that forum and other forums. So glad to have the two gentlemen once again, come together after the first session here on this panel to talk about protocols. I just want to quickly again give a chance for people who have not perhaps heard from you, Jegajith and Chatrapathi, if you could just introduce yourself briefly before we move to the actual session and the questions.
Yeah, and thanks for this warm welcome speech. And I think people have seen our face. I think this is our third phase, but those people who is attending this session first time. I'm Jegajith, so I'm heading the embedded business practice for Utthunga. So basically, I'm carrying almost 16 plus years of experience into various product development, especially into the industrial automation and as well as something related to aerospace and other domain. So my area of interest and definitely the subject or expertise is completely into the device engineering or anything related to the embedded perspective and low-level protocols.
Thanks, Jegajith. Chatrapathi, from your side.
Hi, Anand. Thank you for this. And I'm Chatrapathi. I have about 18 years of experience in this industry. And throughout my career, I worked on different communication protocols, industrial and non-industrial. And at Utthunga, my primary focus is on OPC and other industrial protocols, whether they may be getting ported to an embedded device or they may be working in a cloud application gathering data from different assets. So yeah, that's where my focus is. And I represent Utthunga at different consortiums that maintain the specifications of these industrial protocols. And some of my colleagues and team members participate in the working groups as well at specification level. Yeah.
Great, thanks, Chatrapathi. And as I mentioned in our first session also, I couldn't have thought of two better qualified people to talk about protocols and really take us through the technicalities as the use cases of these protocols than the two gentlemen we have on the panel today. So before I get started, I just want to play a short video. In fact, it is so fresh. It is just fresh out of the oven right now. We've just created it, and it's still going to go through some polish. But I believe you'll probably like it. We just going to, this is all about protocols today, right? And so protocols take the data from one point to another. They change the, not the value, the meaning of for different stakeholders. What it means for a sensor in terms of flow could mean something else for the DCS. So just kind of give you help you imagine, the power the protocols play. Just want to quickly play this. It's a long video. It's about 4.5 to 5 minutes. I'm just going to play through it, and then we dive into it. So just give me a second here. Great. Well, thank you for tuning in, watching that, and with the context, the amazing power that protocols play in the life of an industrial ecosystem. Let's dive into and the first application that I really want to question and get some insights from our panel is on the protocols around motion control. So motion control is a field that deals with moving parts in a controlled manner. We would have components like a controller, a drive, which is perhaps connected to a motor, which could be stepper, servo, linear actuator, and there's so much motion and there's so the question here that I want to throw, perhaps Jagjit, if you can start with is what is so peculiar about the motion control area and the aspects about motion control that governs the choice of protocol that would meet the needs of motion control? If you could throw some light on those, and then perhaps we could understand some of the protocols that really play a more significant role for motion control applications.
See, obviously, and see when it is come to motion control, it's not how fast we can communicate it. It's moreover not the chunk of data. It's moreover it's the time is very critical because, say, example, if you're taking an example of a robo or a servo motor drive or any other things, in that cases, what happen? The data transmission time. Say, example like. A conveyor belt. Take an example of a conveyor belt. Before getting into the protocols, I would like to give an example. And a conveyor belt where it is controlled as a servo drive or any other VFD kind of a systems, and it has some various sensors. And due to some kind of a scenario or kind of an situation where if you want to stop it, so there are emergency brake and there is a system. So similar way, these systems also connected to a large network of sensors and other things. The immediate thing is the response time because the data has to communicate from a sensors to this particular actuation in a very short period of time in case of an emergency stop or in case of any action. So when we are talking about motion control, speed of communication is very critical. So the protocol which is commonly used in the motion control is EtherCAT, because EtherCAT is something which is framed using the same standard typical Ethernet connector, but it is using some kind of a physical layer requirement to transmit this data. The fundamental principle is something like that. Even though if you are using Ethernet type of a connectors. So end of the day, what happens? This data will be exchanged from the MAC layer itself, which means that it is going to abstract the data from the hardware abstraction layer from the physical layer itself, and it has its own topology on top of it. One example, servo over EtherCAT is one profile, or distributed clock is one profile, and this will work in a daisy chain network. So that even though if you have one line of data and it is disconnected, it can follow the other line of connection also. So that is popular, and in terms of speed, and still people are using Modbus also in the motion control, say example, but it is not like a real-time control. Sometimes if you want to change the parameters of a motor or a servo or in that matter for a robo application, you can use our Modbus, which is 40 years old. I think Modbus is applicable for everywhere, and but in the configuration perspective. Apart from that, Profinet is also playing a major role in any of the IO or motion control perspective. And plus Profinet IRT and RT is also playing a major role, which is coming into the real-time control aspects. And of course, I think Ethernet IP also has a flavor. I'm asking Chatrapathi to pitch in on Ethernet IP use cases related to motion control.
Yeah. So, Anand, yeah, any of these motion control applications, they commonly have a mechanism to synchronize their clocks and then to deliver the data precisely at a specific point of time where that specific timeline is common across all the participating devices of that specific motion control application. So when it comes to Ethernet IP, there are two specific SIP features. One is SIP sync, another one is SIP motion. So SIP sync defines how all these different participating components can have a common clock, uh, and then SIP motion allows the devices to exchange their data on the same common timeline precisely at uh, precisely as per the application's requirement at a specific point in time. And all of this is done on a standard uh, Ethernet network. There is no additional requirements or physical layer changes or any other type of changes are required for this. At least when it comes to Ethernet IP, and then of course. Profinet and Profinet IRT are also used for motion control, and EtherCAT, as Jegajith already mentioned. Yeah. In addition to this, nowadays, as you may know, many of these Ethernet-based protocols they are standardizing the different TSN-based profiles, and with the combination of using TSN technology and defining specific profiles on how a specific protocol can transfer its own data over TSN, the protocols are becoming more and more deterministic in terms of delivering the data exactly as per timing requirements. And in that sense, these protocols can be easily adapted to fulfill any motion control application requirements as well.
Okay,
Yes, that's
great.
the exact point which I would like to bring in, because uh, the going forward with the TSN based network, maybe any protocol can fit into a motion control application also when you're talking about a deterministic network. Because yeah, but there are some use cases for EtherCAT specific applications which we can do a very detailed dive when we take a webinar on top of it. And also you can refer some of the webinar what we conducted related to EtherCAT.
Correct, correct. Great, great. Thanks, guys. Of course, Chatrapathi, you mentioned about TSN, and then Jagjit added to that how TSN perhaps then enables any protocol could be adapted for motion control. But perhaps in the current landscape, or the
Mhm.
current situation, what is it? And I'm just asking this question to kind of create a contrast. What is it about some of the other protocols? And you mentioned earlier, Jagjit, that Modbus sometimes you gets used for motion control, but definitely not the first choice and not the popular choice. So what is
Yeah.
that these protocols don't have that don't make them so applicable for motion control applications?
One is the deterministic characteristic, because when you say anything on a real-time control, the data has to deliver within a determined a time of frame, or I would say in a fixed time. So in that cases, the Modbus, definitely Modbus can be used on top of Ethernet, so which is Modbus TCP IP, or Modbus has to travel over RS-232 or RS-485 physical layer. So both this electrical specification or the communication layer has its own limitation. Because when you talk about TCP, of course, it has to penetrate all the layers of the different Ethernet layer till to the application layer. So definitely the data exchange is going to give a lot of latency in terms of data processing on a real-time application. That's the reason this is not preferred for a real-time communication. But nevertheless, take an example like it is not very critical, and you really, if you want to change the set point, say example, if you have a servo or any other motion control, any other robotic system, which periodically, if you want to load some profile or change some set points, which is not very critical in terms of delivery of packet, in that case, definitely we can go with any of this protocol. So it is not a restrictions, but when you say motion control, when it's for a high speed thing, definitely we prefer anything related to TSN or EtherCAT related things. And one more thing, TSN is a network protocol, not a communication things, because TSN define various standards in terms of the network layer. So since once it is facilitated that particular network layer and the complete infrastructure is agreed for TSN, all protocols will work based on that deterministic network. And
Okay.
apart from this, people can use any standard communication interfaces, right? I would say like if they have an RS-232 interfaces or RS-485 interfaces, we can use a custom protocol also to configure and communicate that.
Okay. So just one thing that comes to my mind, I'm not sure, you sort of touched upon without necessarily using the term, but is redundancy an important part in motion control applications and protocols? Do they enable, or do they have to be able to support redundancy? Any thoughts on those areas? Any of you guys?
Yeah, yeah, of course. Because take an example like any. I think most of the system, when you see in the industrial application, which will have a rotary equipment, right? So in that case, if you see, there are some equipment where the safety is a very critical element. Take an example of a lift or a forklift or something, where if it is doing some action and because of some any communication issue, it should not stop or it should not misbehave. In that cases, definitely redundancy is also one aspect. So when it is come to the EtherCAT can assure, since it is using a dual port network, and when you have a kind of a complete DC chain network, EtherCAT is offering the redundancy in the network itself. Apart from that, we can also have a redundant network. Example, Profinet. Profinet is also offering the redundancy aspects. Protocol by default as a protocol. And apart from this, there are redundant protocol like uh, anything we can make with a based on a voting logic kind of a concept, where function safety aspects we can consider, and we can have a dual system to ensure that this is redundant. Otherwise, protocol perspective, EtherCAT and Profinet has built-in feature where we can ensure the redundancy aspects. Chatrapati, do you want to throw some light about HSR, PRP, or something like that, which is of a
Yeah.
known?
So HSR and PRP, these are they work at physical layer redundancy. So uh, even if one of the channel goes down, then the other channel will continue to work, and there is uh, almost there's no switching delay in terms of detecting and switching to the other one. And there are a few other redundancy protocols like DLR. It is specific to Ethernet IP devices, and it also supports redundancy in terms of media failure. Like if one of the ports or one of the cable get disconnected, the overall system will continue to work. It will definitely throw a warning or alarm saying that there is a failure at a certain point, so that it can be taken care while the system is still in running condition. And keeping this aside, at the application engineering or application design perspective, people design redundant systems, like having the entire system replicated, including the cabling, including the controllers and everything, and they would have a little customized mechanisms to detect failure in one system and switching to the redundant system. It all depends on the application specific requirements and how critical the application is, and to what extent it can sustain a specific value. So based on that, they would create a redundant system starting from replicating each device, or to a level where only a high level controllers are redundant. The devices are all single instances. So it depends on the criticality of the application.
Application.
Yeah,
Okay,
one
great.
more thing I would like to, oh, sorry, Anant, to add
Okay.
here.
The reason
It's,
I laughed was, I'm sure we could spend a full day just talking about motion control,
oh
but I
my God.
really,
Okay, then
yeah,
I'll add a few more points here, because whatever we are talking about, it's all master slave technology, because we talk about only the terminology, what is redundancy and speed. But for the audience, it's definitely when you're talking about a system, anything on the industrial automation protocol. I mean, most of the industrial protocol, I would say, like it's working like basically a master slave system. So we'll be having a master and slave in case of EtherCAT, we have an EtherCAT master and EtherCAT slave. In case of Ethernet IP, Profinet, we'll say Profinet controller. And so this is we are talking about in an assumption that people will understand about this complete hierarchy about this network architecture.
okay. I probably have more questions, but I want to be able to cover other application areas for our audience. So I'm going to
Yeah,
stop
sure.
there for motion,
Yeah,
and
sure.
great, thanks. And move to the next topic, which is the traditional, the controllers, the PLCs and the DCS, and they are slightly different. We sort of heard a little bit in terms of the requirements. Motion controllers would have a different requirement. So again, PLCs and DCS need to communicate with remote IOs, other controllers and devices, and software systems like SCADA and HMI. So question here again, perhaps Chhatrapati, you could get started, is what's peculiar again about this set of products, hardware controllers, that necessitates choosing certain kind of protocols, and which are the popular protocols in this area?
So again, Anand, the controllers, when you say controllers, like uh, specific OEMs build specific types of controllers which are suitable for a different types of applications. And again, the requirements of application is actually drives the protocols that are to be supported by the controller. But one changing trend that I've been seeing is many of the controllers nowadays are coming with multiple protocol support. Like when you are initially configuring it, you can enable specific protocols on the controller. And in some cases, they are coming with add-on modules to support a specific protocol. So that way, it is more uh, sustainable and manageable, so that they can support variety of applications using the same controller, but by adding capabilities of communicating over different protocols. And in the recent times, there are different types of controllers with very open architecture. They are coming into the market as well, where including the application, including the stack, including the specific protocol, everything is completely a software configurable. The controllers are no longer built for a specific protocol. They are like general controllers. You can look at it uh, as an Android phone where you are downloading and installing applications, right? So similar to that, you can download the different uh, supporting protocol modules to the controller, and it would automatically have that specific capabilities. Of course, there are few specific parts where there is a hardware dependency, like supporting Profinet IRT or supporting EtherCAT. That's where it doesn't meet that specific applications. But otherwise, for the most of the Ethernet based protocols, these controllers work well.
Okay.
Yeah.
Okay.
Again, Anand, just to add that, because the controller protocol, when you said, I think we need to segregate into two set of industry, because process industry, various protocols like HART or anything on the Fieldbus, and nowadays Ethernet APL. So those things will come where Ethernet APL can have a multiple protocols on top of it, and wireless HART. From PLC to the upper side, definitely the SCADA or anything on the DCS side, definitely Ethernet IP or Profinet or Profibus, or in that matter, any other Ethernet protocol can work on
Yeah.
top of it.
Yeah, yeah, absolutely. And I mean that uniqueness of those two kind of industries, is definitely plays a role in the choice of protocol. So just kind of to take that top point further, Chatrapathi and Jagjit, let me just pick two areas, that come to my mind right now, and just get your thoughts. Let's pick power, as one of the other, major, yeah, industry out there, and building automation. So you spoke about discrete and process. I'll skip those now to power. So we have backnet as one of the popular protocols, in the building automation. In fact, I heard somewhere that, in US, certain states have mandated that their buildings and all the things, the HVAC systems and whatever get installed, have to support backnet. So just want to hear your thoughts about what is about backnet that, it makes it so suitable for, building automation, where we control dampers and, flow meters perhaps, and HVAC systems and even lighting systems. So a little bit, from a backnet perspective, and peculiarities of the building automation generally. What do they need from a protocol?
Yeah. So basically, Anand, on the building automation side, BACnet and Modbus has been popular protocols for a very long time. And as you know, Modbus has its own limitations. And BACnet comes with a uh, way of data modeling in terms of creating objects and different services, linking to the objects to services. And that way it is very easy to uh, define different devices fitting to different profiles. So like, for example, a simple IO controller which can simply turn on and off the lights, or a little better controller in terms of reducing or increasing the brightness of the lights and then turn on and off, and similarly the air conditioning or the lawn sprinklers, doors opening and closing doors, and any intrusion sensor integration in terms of windows and doors, and so on. So, and then there are controller profiles as well, and supervisor profiles, controller profiles as well, where the controller talks to all these IO profile devices, and it can be configured, and many of the lighting systems and as well as the sprinklers and other systems can be activated. You can create schedules based on when to switch on the common area lights and when to switch them off, when to open the blinds, and so on. So that way it is really flexible because the protocol itself is built for building automation. So yeah, it's kind of a very strong synergy between BACnet and
Okay. Okay.
the
So some
building.
of the things that you mentioned, but also, because we spoke about motion control and other, the aspects earlier, perhaps the protocols here need not necessarily be high performance, because these are values that don't necessarily change that fast. Is that a fair assumption assessment in terms of building
Uh,
up?
yes and no, because see, when we say building, we're not just talking about a residential building. So if the building itself is a factory building, right? Now, based on how these HVAC systems and lighting systems and other ventilation systems are, these systems are working, there has to be some kind of horizontal integration between the actual process. Like if HVAC system is failing, then it would affect the process because the process requires certain temperatures and cooling needs to be maintained, right? So that kind of horizontal integration in terms of wherever it is required. So for those alarms, it is critical in terms of timing. But again, the duration is not as quick as a motion control application, obviously. But other than that, for most of the cases, yeah, the cycle times are pretty low in building automation. Yeah.
God. So just quickly, in the spirit of time also, but let's talk about something from the power side of things. And, we have other protocols,
Yeah.
DMP3, 61850. Now, in power, of course, is the world of substations and process equipment like drives and voltage transformation, current transformation, reclosers, so on and so forth. So again, the needs of this domain, perhaps, perhaps more high speed, motion control, a little different. So what is it about, let's say, IEC 61850 that makes it relevant to have communication between the IDs and the bays and the other areas?
Yeah, so there also, like, more than the transportation, IC 61850 is a little more on the data modeling side. That's why it suits the power industry, like different objects and uh, different ways to model the data that comes from the lower levels. Just like how you have shown the video where the different protocols are being used to exchange data between different layers. So the same type of video can be replicated for power generation and power distribution systems with their own protocols, if you know what I mean. But then there are commonalities in terms of some of the protocols, like Modbus is used still in many places, and in some places SNMP is used as well. And however, at after certain layer, again, they all have companion specifications to represent their own data in OPC. Like BACnet has, and IEC 61850 also has a companion specification to represent the data over OPCs, and that's where the convergence happens.
Okay. Now, is the communication or the transmission of some of the important data like alarms or events perhaps more important here, to avoid blackouts in certain areas? If I speak
Yeah.
a little broadly, these protocols perhaps have natively certain features that make
Yes,
that.
they natively support such features, and they natively take care of such things. And again, for a uh, for a next level of decision making or for next level of management. Again, through OPC, they can still deliver the same alarms and events as well. Yeah.
Okay, good. Okay, great. Let me move to the third area, that I believe would be of interest to people, already tuned in, is the safety protocols. Now, when we say safety, functional safety, is a field that combines quality, reliability, and systems engineering to implement risk, management techniques in electrical and electronic devices. Now, when we say risk management, it is to avoid physical injury, to humans or other people there. Now, protocols, of course, from what I understand, and of course, in my conversations with you guys and Jagajith, also it's not that the protocols play a role, per se, in enabling safety. It's the standards, the mother standards of all, like the IEC 61508 and various derivatives of it, perhaps how they get implemented. But the protocols perhaps play a role to make sure that the data get transmitted without, in time, without latency in other aspects. So again, peculiar needs of the safety applications. We have so many safety protocols out there, and a lot of those that you are very familiar with. So if you can share again, what is that specific about the safety needs that the protocols could really play a role in, and some of the popular protocols that are used in the industry. If you can throw some light on those aspects, Jagjit, and then Chatrapathi after that.
Yeah, so Anand, as you said, yeah, the safety is, we cannot ensure safety only with protocols like, the communication we ensure the so safety term itself we need to define first. The safety is something that it is not like anything like to avoid any catastrophic or any other dangerous situation. So entire system has to accept, or the entire environment or the system has to go through some certain standard to ensure the safety. So safety could be something. It's not like that. System will not fail. Maybe system can fail in a fail-safe mode, where there is no a major casualty, or the things are not going to happen. So such kind of things can be taken care of. So the safety standards, whatever we are talking on the protocols, all derived from the fundamental safety as we discussed already. So one example is the PROFISAFE, because PROFISAFE is already defined various standards in terms of the communication aspects. Again, it's as I told, it is not limited only with the protocol aspects. Sometimes we need to go with the redundant, uh, uh, the communication aspects in case of any cable disconnect or physical layer failure. How exactly this is going to communicate and ensure that system is communicating the critical informations. So in that cases, ProfiSafe is one example where it has a various standard which is defined for safety level communication. So most of the safety PLCs and IO controller people are using the ProfiSafe standard. Similar way, Ethernet IP, SIP safety is one of the function safety aspects which is defined, and Ethercat also safety things are defined. So the fundamentally your entire system uh, has to ensure that what level of safety we are going to do it. So safety can be divided into various function safety, like SIL 1, 2, 3 level to 4. There are some different safety level. Based on that, we can decide that. And one more thing, like say example, your protocol itself don't have any safety definition. One example like a Modbus, or you might be working with an RS-232 standard protocols, but your system still demand for safety thing, but the physical layer is already defined, or there are some limitation to use such kind of scenarios. Definitely, we can ensure these communication also taken care all the safety related things by doing this voting logic or various other redundant mechanism, or creating a heartbeat kind of an applications, or we can go with the standard safety protocol also.
Okay, okay. Chatrapathi, you want to shed some light from SIP safety perspective a little bit?
Yes, Anand. So basically, SIP safety is built on top of the industry standard functional safety spec, and the SIP safety ensures that the rest of the device implementation, of course, falls in the functional safety standards framework, and then the protocol itself ensures that the safety data is uh, transferred, and whenever it sees an anomaly, it raises the flag and pauses the system, or gets the system into the safety mode, and so on. So uh, in terms of uh, in terms of infrastructure wise, like it is not a, again, the same existing network itself can be used for both safety data and as well as non-safety data. um, yeah, so main thing is having the rest of the system functionally safe, and only then having that specific protocol specific safety aspects implemented on top of it. Only then the overall system becomes a safety system. So protocol by themselves won't ensure anything with respect to safety.
Okay. I have a lot of questions to ask here, but maybe I just want to jump to one area, perhaps a little early. I'm not sure. OPC UA seems to be also having something around safety coming up, or
Yes, yes, Anand. So, as part of the field level communication group, the group that is working on the OPC FX specification, as part of that, they have already developed a safety specification with which systems can exchange data over OPC UA, and still the overall system safety is maintained, and they already have a stack that has been developed, and they already have safety system demonstrations at the recent uh, Hanover Expo as well. Yeah, so they are pretty much aggressive on pushing the OPCA FX safety. Yeah.
got it, got it. Okay. Of course, both you guys were there at the Hanover, and so yeah, you've seen firsthand, some of those demonstrations. Okay, let me now quickly move to the next segment. Now we move so we from the controllers, and but let's come down a little bit in the pyramid. Let's come down to the field devices, the sensors, the actuators world. Perhaps not so different. We'll probably end up encountering similar protocols, but again, just wanted to pick your brains here and to see what is it, what kind of protocols are most suited for connectivity communication, because there are certain needs that are definitely still not present in the layers above, perhaps diagnostics, perhaps discovery, perhaps something else. So I want to hear from you. Perhaps you can choose a couple of protocols to make your point around what are the kind of protocols that are most applicable at the level zero of the automation pyramid.
Yeah, so again, this has to classify it into process and the factory perspective. And again, when you're talking about the sensors, actuators, and field device protocols, the one with the criteria, which apart from the data, power is also one important criteria here. So the popular protocol for anything on sensor actuator is HART, which is almost all the process uh, automation or the process industry. The most of the sensors and actuators are people are using HART. So HART one advantage is something that HART, of course, it can transmit both analog and digital data by providing a field level power to the sensors or actuators. From a HART master, or it could be a DCS or something like that, which is very popular in market. It's basically a two-wire communication interfaces. And now, recently, definitely, IO-Link is also playing a major role. So IO-Link needed extra power, but IO-Link has a lot of features when it is when we are discussing about sensors and actuators. Specifically, how we are using in HART, and similar way there are IO-Link device descriptor file. It's known as IODD, which will define the various configurations and parameters about the sensors and actuator specific. Again, these things are working on master slave principles. And on top of it, since I discussed about HART and IO-Link, these two, the wired interfaces has its own wireless flavor also. There is an IO-Link wireless, which is actually a device can be deployed in a field, a battery operated devices that can be talked to an IO-Link master over wireless. And similar way, there are a lot of wireless HART device also available in market, which is very popular in the field level communications. Apart from this, Modbus is also one of the known protocol. People still using Modbus for talking to sensors and actuators. Even we have witnessed recently with one of the OEM when we visit the factory, we have seen that they are still using one of their latest devices, a Modbus protocol for the field level communication. And apart from this, Industrial standard protocols, field level devices are communicating over Bluetooth, even some gigahertz, even some proprietary protocol over wireless also very much popular. Because
Yeah.
this is from L0, the sensors and actuators will talk to the PLC, or it could be a SCADA based system, or it could be a controller where it has its own receiver or the master to receive this data. And from there onwards, whatever we have discussed in the previous discussion, like Ethernet IP, Profinet, or OPC, can take over from the other layer.
Yeah. Yeah.
And
And you mentioned, yeah,
I would
please.
like to highlight APL also here because this is also going very popular Ethernet APL because it can carry multiple protocol to the field, and of course power over data is also one of the features, and we do have our reference design, and many OEMs are converting their devices, especially the actuators and sensors in the process industry where power, they don't want to have an extra line for power, so the two wire interfaces itself and carry power and data.
Yeah. Got it. Absolutely. And on a final note, you mentioned Modbus. I don't think Modbus is going out anytime soon. The granddaddy of all protocols probably continue
Yeah.
to operate for a long, long time. Just quick question, before I want to ask an OPC related question again on this topic. So on this field layer, we of course see a lot of configuration, commissioning sort of activities happening. Anything from that aspect that you think makes a certain protocol relevant or usable, or do you think no, that's just it's not so applicable in terms of commissioning or configuration, activities of these sensors of these devices.
See, OPC is also playing a major role. Like when you're talking about, that's what I said. These devices are working on a master slave configuration. So definitely these sensors has to connect to a master devices. So most of the cases when we go for the deployment, there are two level of configuration you can do it. Either you can configure the slave devices as it is, or you can have a slave device can be connected to a master with a basic configuration. From the master devices, you can configure it. So when you're talking about a big cloud level connectivity, definitely OPC is also playing a major role. Talking from a PLC or any other IO devices or a gateway that can be connected to the cloud, and we can do a remote configuration also. And plus OPC FX is something which is a field level communication is also the specification is also, I think the release candidate one or something is released now, and that is also one promising protocol which going forward these devices are uh, going to utilize it. So maybe Chatrapati, you can do, maybe you can throw some light on OPC FX.
Yeah, sure. So, Anand and Jegajith, for most of the sensor and actuator level or low level devices, having a very flexible model of configuring these devices and being able to fetch rich diagnostics data from these devices and doing all kinds of calibrations and measurements, and then so the from that aspect, they are different from rest of the industrial protocols and any of the low level protocols that support these type of features in a user friendly way, and even from uh, the data model perspective as well, are popular in these areas. And Ivolink has a very rich way of representing these diagnostics, and then being able to download or save the entire configuration of the master and the underlying devices uh, in a format, and then being able to push it down to um, being able to replicate the same system by having that data over rest of the places, and being able to store this data somewhere else in the upper layer protocols or storage systems, and being able to send it to the place wherever you want to replicate the system. So these kind of features is what actually drives the selection of protocols at a lower level base. And then yes, OPCFX, since it is targeting the field level communication as of now, device to device, device to controller, controller to device, this is the primary focus now. And for that, different file formats are being defined in terms of downloading and uploading configuration and so on. Different tools are being standardized. and different interfaces are being standardized. So yes, so with respect to the actual sensor and actuator level, I haven't uh, got myself familiar with that part of the spec. Yeah. But for
Okay.
at least device to controller, controller to controller, these communications I can see happening, and only process specific with sensors and actuators, how it's going to pan out, I still need to get myself familiar.
Okay. It's an evolving story also from the
Yes,
OPC
yes,
Foundation. So yeah,
yes. So
great,
as of
great.
now, it is in release candidate 3, and then yeah, release candidate 3 it is. Yeah.
All right. Well, we've got 10 minutes. Let us now move from the bottom of the pyramid to the top of the pyramid. Spoken enough about protocols at the OT layer, the controllers and the sensors and the field devices. Of course, all this data does not now in the very highly converged world of IT OT does not stay at the OT layer. Most of them actually make their way to enterprise IT and cloud. So let's now talk about what is it about the IT enterprise cloud applications, and perhaps you have business intelligence applications, MES applications, CRM applications, other customer facing, various outside facing applications, not internal OT facing applications. They of course have a different functional role to play, different need to fulfill. So, question again to both you gentlemen is, what governs the choice of protocol, in this, part of the automation pyramid? Chatrapathi, if you want to start.
Yeah, so Anand, in most of the cases, the protocols were any generic data transfer protocols that work at IT level, like MQTT, if you look at it, or AMQP, or any other customized client server based or TCP based. So there are, it was very much uh, diversified in that sense. Uh, but we are looking at more and more, like even we had a serious discussion on this same topic on how do we maintain the context and essence of the industrial data when things keep moving upwards into the pyramid. And for doing that, what choices we should make, and what kind of design choices, what kind of protocol choices we should make, and in terms of data modeling and in terms of data representation, what we should carry out at each of these levels, this we had discussed. So uh, only having such an overview from top to bottom, and having defining such requirements for a specific system and following it throughout the pyramid makes sure that you have the essence and quality and context of the data that you are carrying forward. Of course, at the end, for the actual transportation, some of these protocols are only used, like if you look at OPC PubSub specification, it standardizes how uh, the industrial data or the OPC data is transferred over MQTT and AMQP at the upper levels. So AMQP and MQTT is still used, but it not like a not everyone can come up with their own customized format and simply use it for publishing. So that kind of standardization is happening, but the actual transport mechanisms are still going to be used, whatever currently they are there. And if there is a database storage, like OPC comes up with a standard on how you can store a historical data and how it can be retrieved back. So in the end, there's going to be some database, but the way you are storing it and the way you are retrieving it makes a lot of difference. So uh, when these standardized approaches, standardized interfaces, and standardized models are not used, then it is just a uh, IT system. But when these things are introduced, it becomes a industry specific IT system where it is aware of what's going on in the down layers, so that context is maintained. So uh, that's what it is.
Okay. Okay. Now, I'll just ask one final question here, again, from the negative side of things to make it obvious as to why, certain protocols make more sense for the IT layer. And I've seen this in my, in my experience also. Some people have tried to send Modbus packet all the way up to the cloud, and then they have their own application, unbundling it and making sense of it. But it's not suited for that. So what makes Modbus not
So,
suitable?
Anand, it is basically uh, see, you may do it like it is possible. So, Ethernet IP, if you look at it, it is a standard network based protocol, and you can still connect. It has an IP address, so anything with an IP address you can connect to and get the data from it. The only thing is, as you are moving one level up and one level up, it's not that you are dealing with only Modbus devices or only Ethernet IP devices, and the values also carry different meaning from who is using the data at each of this level. So there's no point in making each and every level aware of all the industrial protocols that are going down below, and because they're designed for specific things which they are really good at, and only the required data, required context and information need to be carried out, and from that perspective, yeah, OPC does an excellent job. So,
Fantastically summarized. I think makes a lot of sense the way you explained it. Good, great. Well, we've got 2 minutes, and I want to get the questions squeezed into, before we close. So let's. We've got some questions out here. I'm just going to go through the top and ask a few. We've got less time. We might have to extend by a few minutes. So I really request people to please stick on. The first question is. Certain protocols like Ethernet IP are object oriented. Now, what does that really mean from a client application perspective? So, Chatrapathi, you want to take that up?
okay, so from the client application perspective, it gets to use a well-designed data. Like it exactly knows if it needs a certain piece of information where it should go and look at it. So, for example, if I need an identification data, like what is this device, who is the vendor, what is the firmware revision of this device, what is the serial number of this device, I know I need to go and look at the identity object. So from the data modeling perspective, everything is well placed and well designed, so you know exactly where to look when you need a specific data. So, but maintaining that same context when the data is passed on to the upper layers, that's where you need to uh, do the rest of the work. But within the system, yeah, it's a well-aware system. There's no confusions, no need to refer to data sheets or something else, because everybody knows any Ethernet IP device, you refer to the identity object to get the identification data. Nothing vendor specific, nothing device specific for most of the basic operations. Of course, a device with a vendor specific rich features, and they would have published the specific objects and the services that those vendor specific objects support in their documentation, product documentation. But still, the way to access them is common. The request format that you would send to fetch that specific object details, it's already known to everybody. So that kind of advantage you'll get it.
Okay. Let me run through a few here. We've got one says wireless HART requires new devices to be authenticated before they join the network. How does the protocol ensure that? How does the protocol? Yeah, I guess the question is, I mean, what role does the protocol play in this? The wireless HART protocol.
See, the wireless again working with the mesh technology, and it has its own device ID and information, so that when you have a host devices, say example, when you have a master devices, you have a configuration to accept it, which is going to be there in that network.
Okay. All right, I'll just pick one. We'll run out of time. There's the last one, or there are quite a few, but I'm just going to pick one. In terms of cycle time and jitter, which is the most preferred communication protocol for motion control applications? I'm not sure if such metrics are available. It's
No
yeah.
doubt it is Ethercat.
Say that again.
EtherCAD.
Ethercat. Yes.
Ethernet. Okay. All right. So there is a clear answer. I didn't. Okay. I didn't think we would get a clear winner there. Got it. All right. I believe we've probably
So
got some.
there's just one catch, Anand, there. So like EtherCAD uses a specific hardware change. It's not a standard Ethernet based. But if you are looking at standard Ethernet based, Profinet RT and Ethernet IP with SIP sync and motion, they are pretty good. And any of these protocols with TSN enabled technologies, the Zitter and frequency.
And like I guess what you're referring to is the on-the-fly processing that Ethernet does.
Yeah.
All
Yes.
right. Let's close now, and I think we're at the end of our series. We've gone through 3 sessions. Hopefully these sessions were helpful. People tuned in. A lot of people have watched it over LinkedIn, the feed, as well as YouTube. So thank you once again, everybody, for joining. Thank you, Chatrapathi and Jagajith, for sharing your invaluable insights, with everybody here, and I'm sure it was helpful. Before I close, though, I just wanted to, bring in just a little bit about Utthunga, because we've not spoken so much, about. I really want to share that when it comes to connectivity, industrial connectivity, of course, in particular, that's the foundation of our company. We've sort of grown that way to enable devices for connectivity. These could be digitally native devices. Get the data out of those. If you're not digitally native, make them digitally aware so that they can give the data. Standard protocol, proprietary protocol, more emerging protocols, from OPC, the entire landscape. We've done it for L0, L1, everywhere else. So I really, if in case you have needs around those, looking for, connectivity support across the spectrum of devices for the industrial landscape, from sensors, controllers, and OT software, and up all the way to the cloud, we probably we have the experts to really help you there. So with that, let me also ask you, that we've got, request you to all follow us on LinkedIn. That's the place where you get all the information about us as a company in terms of, various messages that we put out there. We've got one session coming up next week, actually, in a week from today. It's a very interesting session. Again, an extension of the various work that we do on connectivity. It's with the single pair Ethernet SPE consortium, where Mr. Matthias Fritz from Harting, he's going to be talking about SPE and the role this two-wire, is going to play, at the field level, really. And how SPE really is going to really make IoT a reality, where sensor to cloud connectivity can happen over two-wire connectivity. So that's it. And I know I just want to give final words. This is the last session of the series. So Jagajith and Chatrapathi, if you have final words to share, anything that you want to, before we close.
Yeah, I
Yeah, I
think
think
this
we
session
covered the entire automation pyramid and various protocol, and we also enjoyed this session. I think
very interesting
the
and exciting
yes,
topics we had.
Yeah. Yeah, feel free to reach us through our website, through our email ID, contact@utthunga.com. If you have questions for our experts or any questions around connectivity or any product development around industrial, aspects, we'll be very happy to, talk to you and get a right experts to talk to you. Thank you once again. Thank you so much, Chatrapathi and Jagajith.
Thank you.
Good day, everyone.
Thank you.
Bye.
thank you.
Bye. Bye.